Learning target 2.8, I know that electronegativity differences between atoms results in polar covalent bonds. Okay. Remember that electronegativity is the ability of an atom to attract electrons towards itself. Right. Another way to think about this is the ability of an atom to take electrons from another atom. Okay. If you ever have looked at all the electronegativity values on the periodic table, which turns out I have a handy list of them right here. So instead of just the atomic number and atomic radius, and atomic mass, we're looking at electronegativity values. Well, it turns out that metals and nonmetals on the right have very different electronegativity values. Okay, let's take a look. If you have a nonmetal, fluorine, I don't know why it says Fl, but we know it's fluorine, and a metal, Na, right, and you look at their electronegativity value, 4 and 0.9, right, well, you'll see that they're pretty different. Well, what does that mean if one has an electronegativity value that's really high and one has a really low one? That just means one likes to take electrons and the other one does not like to take electrons or can't. Okay, it means that one likes to hog the electron more than the other. And which one wants that electron around it more often? It's going to be fluorine, because fluorine has a higher electronegativity value. And turns out my nonmetals, as we have mentioned before, have very high electronegativity, whereas my metals, especially my large ones, have very low electronegativity. Okay? What that means is that you're going to have a polar covalent bond. Okay, let's go ahead and jot that down. So polar covalent bond. Right. Breaking this down, we know that covalent means that electrons are shared. Polar, if you think of a polar bear, the reason why it's a polar bear is because it likes to live at a pole. And it's cold. Here's it snowing on my polar bear. Okay, now polar, you should think of it as the Earth, right? The Earth has different poles. It has the North Pole, it has the South Pole. It's kind of like a magnet. So we're talking about a bond where the electrons are shared, but it's polar. What that all means is that the electrons are shared, but sometimes there's more electrons hanging out here than here. The side, if there's more electrons on one side, electrons are negative, that side of my molecule is going to be delta negative. This side is going to be delta positive, or slightly negative and slightly positive. Okay, so this is a polar covalent bond, and that occurs when the electronegativity difference is large. Like if you have something that's Na bonded to F, right? Na, as we saw before, was 0.9, F is 4. Most of the electrons want to hang around here because he's cooler. Not as cool. Right? Electronegativity difference is large. Okay. Now, if you look at two nonmetals, so let me bring my little chart back. Okay. Let me look for two nonmetals. So let's take a look at O and Cl. O and Cl. O has 3.5, Cl has 3. The values are really similar. In fact, they both have an equal pull on the electrons, more or less. Sometimes they'll want to hang around the O a little more. So Have you guys ever played tug of war? Let's pretend this is a rope in tug of war. You're trying to pull one towards the other side, right? Do you see the analogy coming? Yes. All right. What happens if two teams are evenly matched and they have the same pull? There's not much movement. It jiggles around a little bit, but no one's really pulling the other one away. Okay. So you kind of have to share. Take a look. My two nonmetals, sort of similar electronegativity values. My friends, oxygen and chlorine, will have to share electrons, right? The key here now is that if you have a small difference in electronegativity, then you will have something that's a nonpolar bond. So go back to my crazy page of notes. So we also have the nonpolar covalent bonds, right? And remembering that covalent means electrons are shared. Remember that nonpolar just means no polar bear, no pole, right? There's no difference in electronegativity. So En difference is small, right? So that would be something like O, which is 3.5, and Cl, which was 3.0. Okay, so these are your key ideas here, nonpolar covalent and polar covalent, and knowing the difference between electronegativity. Okay, let's go ahead and try a sample question. The sample question reads as follows. The two atoms involved in a nonpolar bond have blank. Okay, so thinking back on what we just talked about, looking at your notes, nonpolar bonds, no polar bear, no poles. So I'm going to draw my Earth, no poles, no north, no south. So that means my electrons are evenly shared, or the other word is distributed. Okay, when are they going to be evenly pulling? When you have a large difference or a small difference, right? So definitely not a large difference, definitely a small difference. Does it matter if they both are large or both are small? Yes. If they're both large, they're just pulling harder. If they're both small, they're just sort of like both loosely pulling. The correct answer is when you have a nonpolar bond, right, the electrons are evenly shared, so there's a small difference because the electrons aren't going one way or another.